height of a ball. A shot putter throws a ball in at an inclination of 45 degrees to the horizontal. The following data represents the height of the ball h at an instant that has traveled x feet horizontally. So here we go. And here's the problem I usually have with this kind of problem, because the units on this problem is the same for both. Because it says, and here's a picture of the data, this is in feet, because we're looking at it traveling. Essentially, if I'm looking at the ball, this says how far has it traveled along the ground. As it travels above the ground, if you're looking up, where are you on the ground? So essentially you're tracking that thing. Normally it's time coming here. This time it's going to be distance. But this is also in feet, because that's height. So if I look at the input variable they tell me is x, which is distance. Its unit is in feet. The output is, they didn't give me, h, and its distance also is in feet. And then I went ahead and I drew the scatter diagram for you. Now I was able to do that because I can connect my calculator. I can download a free piece of software from TI. There's a cable if you bought a new calculator that will be a USB cable that you can use to connect to the computer. You only use it to, in the new ones, you use it to charge it. Or with the piece of software, your computer can talk to your calculator. And I can actually get a screenshot of what's on the screen using TI software. It's called TI Connect, and it's free. And you can just download it from their website. I like it because I can, as you can see, I can take a picture, I can put it in things and that kind of stuff to do screenshots. So the first thing I do, it says use a graphing utility to find a quadratic function to 2 decimal places that best fits the data. So now I need to input my data. This is where it would be nice if it were like a real spreadsheet, which means that the data is separated by 20. So that means that if I could start out with 20 and then do the next one, and it says add 20 from the next ones, but that doesn't work that way. So 20, 40, 60, whoops, you guys are better than me, 60, 80, 100, 120, 140, 160, 180, 200, and 25, 40, 55, 65, 71, 77. This tells me approximately, by the way, where the vertex is. Notice there's a 77 and there's a 77. That means that you have a 77 going up, you'd have a 77 coming down. So that says it's somewhere between 120 and 140. Because there's only way you can have 2 y values. One, the same y value going up as you do coming down. Then 75, 71, 64. And then I noticed that does my data line up? Nope. So 64. I didn't have my 2 77s. 71, 75, 77. I was too busy talking about it and forgot to put in second 77. Okay, so now my data's in, and it says a quadratic function. And a quadratic function now says, what do I need to do? I need to calculate. So stat, calculate. Now if you go down, you see number 5, QADREG. That is quadratic regression. And press enter. Now this looks like a quadratic, so should my fit be pretty good? Yeah. And now my quadratic regression, and I say, oh, go do it. And now notice I've got an r squared and not an r. R squared is the square root of r, so or is the square of r. So that means if I want my correlation coefficient, I have to take the square root of that number. So to what? 2 decimal places? I lied. I need to make it 3. Now, why would I make it 3? To 2 decimal places, I lose a. So I can't do that. Needed 3 decimal places. So it's going to be h equals. Now, a is negative 0.0037 blat, 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 but 0.0034. That's what I got. Negative.
Okay. Rounded to 3, would it be 0.004?
Oh. 0.004, thank you. Plus 1.032. .032 x, and then plus 5 well, look at all those 6s, that's scary. 667. So that's going to be my model. And now I work off of this. Put in x, get out y. And we're not at the stage yet, I think, where we put in y, get out x. Although we could, because in order to do that, you would need to use the quadratic, let's make that cleaner, the quadratic formula. But that's now my model right there. And let's see, and this would be in feet. So if I wanted to put units at the end, the units at the end would be feet. And I think we'll pick this up tomorrow on this next page. And then we will finish this all off tomorrow.